Don't put that else we can put.
All right, so here we go. In Le Chatelier's principle, or section 2 is all about Le Chatelier's principle, and he said we get to equilibrium. Now we're going to add what he calls a stress, which is just saying, hey, we either add or take away or adjust the temperature, and we want to see which way the equilibrium shifts. So one thing I really didn't mention with section 1 notes was equilibrium is for very particular conditions. We mentioned temperature, but things like concentration, volume, and pressure can also affect it. So any questions on this? Okay, so there's technically 4 stresses, but we clump volume and pressure together. And so we start with changes in concentration. So if we increase any concentration, we are going to shift to the opposite side of whatever substance that we added. If we decrease, we lower the amount of some substance, we shift to the same side it is on. So let's go through this example. All right, so we have our equilibrium. Everything's a gas, so it would be included in that equilibrium constant expression. And number 1 says, which way does the equilibrium shift when more carbon monoxide gas is added? So when we talk about shifts, we're either saying shifting right or to the left of our equilibrium equation. So the first thing that we do, we find that substance, CO, it's on the left-hand side. We've added it. So because we've added it, it shifts to the opposite side. So we would say it shifts right.
So we add it goes right, and we subtract these into the left.
Be careful, because I'll show you here in a second. Now, H2O is on the right. We take it away, or removing it. And so because we're taking away or removing it, it's going to shift to the same side. So removing H2O also shifts right. Now, just the opposite here. We add more H2O. Okay, we're adding more H2O. It's on the right. Adding shifts it to the opposite side, which is to the left. So we say this shifts left. And then our last one here, number 4, we go back to carbon monoxide on the left, and we're taking it away. So it stays, but we say shifts which way?
Left.
Yeah, shifting left because it's on the left-hand side. We're taking it away. It shifts to that same side in which it's located. Okay, so anybody have questions on this and or still need it? Yeah.
So now I'm confused on number 2.
Okay.
So if it was removed, why would it go to
Okay,
So if
because
it's
H2O is already on the right.
Yeah.
When we remove it, it shifts to the same side. That's
So
all.
remove, and you remove it, it stays the same.
when you add it,
Add it shifts to the opposite.
Yeah, add opposite, shift same, or remove same.
Okay, that is.
I don't know the way to put it. Good question. Any other questions? Okay, does anybody still need this? All right, so moving on here. Our second change, they clump these together. Sometimes I teach it differently, volume versus pressure. So let's think about it before we get into the actual notes here. If I had a bottle, this spray bottle has 946 milliliters. Let's say it contains a gas, and I open it up, and it spreads all throughout the room. The room is hundreds of liters, if not thousands of liters. So we increase our volume, but let's say we just had the same amount of gas. What would be our pressure? Would it be more or less, or would the pressure increase or decrease when we get a bigger volume?
Decrease.
It would decrease. Okay, so when your volume increases, your pressure decreases. Now, let's say we take the gas in here in the entire room and we squeeze it all into this one wash bottle here. Well, now we've decreased our volume, right? The whole room down to this container. But what happens to the pressure? Okay, so when we talk about volume, we can also talk about pressure. When we talk about pressure, we can also talk about volume. Now, in particular, Le Chatelier's principle looked at pressure. And so if we increase the pressure, it's going to shift to the side with the least moles of gas. If we decrease our pressure, it will shift to the side with the most moles, or excuse me, with the most moles. I said that. Decrease, shift to the side with the most moles. So let's try an example here. All right. The first thing you heard me talking about moles. It is the total number of moles. How we get to the total number of moles is we just add our coefficients. So over here on the left, and first off, these things are all gases, right? So check, they're all included. We have 1 plus 3 as our coefficients. What's our total number of moles? 4. Good. Okay, on the right, if we take a look at this, we have a 1 coefficient and also a 1 coefficient. So a total of 2, all right? So this helps give us a basis for our next 4 questions. So question number 1 says, which way does the equilibrium shift when there's an increase in volume? So volume, what's happening to pressure? Pressure is decreasing. A decrease in pressure shifts to the side with the most moles of gas.
Shift go left.
There we go. Shifts left because that 4 is on the left-hand side. So number 1, we say shifts left. Now, number 2, it says which way does the equilibrium shift when there's a decrease in volume? So what happens to pressure?
Increase.
Pressure increases, it's got to relieve itself. It would go right because that's the least number of moles of our gas. So number 2, we would say shifts right. Okay, number 3, which way does the equilibrium shift when there's an increase in pressure? It's got to relieve itself.
Right.
Right, because that's the least number of moles of gas, yes. So we shift right again. And then talking about our last item here is this, shift left, why?
Because
the volume goes down.
Okay,
I mean, up.
yes, okay. Decrease in pressure shifts to the side with the most moles of gas, which is that left-hand side with 4, okay? So we would say on this one here, we would say it shifts to the left. All right, any questions on this part of Le Chatelier's principle?
Are those like the 8.4 sheets on the test?
There will be some type of version of it. It may be multi-part, but it's a major component. That's really all we're talking about this section. So I got to include at least some of it. Yeah. All right. Here we go. Our last set of rules, change in temperature. Now, temperature or heat, we can't really technically view it as a reactant or product, but for this process, we're going to add it either as a reactant or product. So if an equation is endothermic, aka delta H is a positive value, heat is a reactant. If delta H is a negative value, aka an exothermic reaction, heat will be added to the right-hand side or the product side. Now, we increase the temperature, it's like increasing the concentration. shifts to the opposite side of the heat. When we decrease or we lower the temperature, it shifts to the same side that we had added that heat. So let's go through two examples, all right? First example here, it says delta H is bigger than 0. What that means is that delta H is positive. So where is heat? Is it on the left hand or the right hand side? Left, because we had to put heat into it. Very good. So heat, we add it to our left hand side. Now we say, which way does the equilibrium shift? With an increase in temperature. It's like increasing a substance, so we increase the heat, it shifts opposite. So what side's opposite? Shifts right. Now we decrease temperature, it shifts to the same side heats. What's that? For this one? Yeah. It would shift, B would shift to the left.
No, I meant for A. You said it should be left.
Oh, A should be shifts right because we cranked up the heat.
And then you
And
add
so
opposite.
it's like adding concentration, so you have to shift or leave it to the opposite side. And then B, because we lower it, it's like removing the concentration, so we have to shift to the same side, which is left. Does that make sense?
Yeah.
Okay. All right, so example 2, in our heat, we have this, it's negative, so what side is heat on?
Right.
Right, as a product, okay? Now, number 2 says, which way does the equilibrium shift? Increase in temperature, so we crank the temperaure up, shifts opposite. There we go.
The next one would be right.
Shifts,
Right.
it shifts
Stay
right.
the same.
Yep.
So if you decrease the temperature,
There we go. So decrease in temperature, it shifts to the same side that's heat on. In example 2, heat is on that right-hand side, so it's going to shift or continue to shift to the right. Questions?
this is too much.
It really is. Last thing, real world application here, hemoglobin. I'm sure you've heard of altitude sickness. Reason for this, hemoglobin, it attaches on to oxygen and it gets it to all your organs and tissues and brain and things like that. At high altitudes, guess what? There's less oxygen, so the equilibrium shifts left. Well, that's the side where hemoglobin does not have oxygen, so oxygen can't get to your brain and your muscles and
That's
things
no way
as
to-
quick.
That's not working.
That's, yeah. You ever watch that Mount Everest movie? That's what happens.
They post the homework. That's what I'm saying.